Hello, hello. Can you hear me?
Yes, we can hear you.
Okay, nice.
Okay.
Thanks. Okay, I think that nobody other will be joining. I think this is the right time. So welcome everybody. My name is Mateusz Kolewiński, as we have already met. Uh, this is the lecture. I just want to be sure that I'm still hearable. Yes?
Yes, you are.
Okay, okay. So nice. Uh, yeah. One thing that I will start recording of this lecture, and probably I'll be recording all the lectures because I was asked about it. I hope this is not a problem for anybody. Whether, in case whether this is a kind of the problem, please contact me on the Teams. We'll try to figure out something more, any other, let's say, solution for that. Okay. All right. So basically, now, how it's going to be. You know how we are going to proceed regarding the project. So there are two topics, or let's say that topics can be merged. You are going to make some kind of the project. There will be some kind of the reports. I will be grading, and so on and so on. About the laboratory, we know that we are gonna have several assignments, and that assignments also will be graded. For both activities, we have some kind of the time to have a ramp up. So basically, we are trying to prepare our environment, our workflow, our, let's say, knowledge about the Python, in order not to be sure that the Python is not the thing that will be problematic for us somehow, and we're gonna use the Python in a limited form. I mean that on the beginner level, but still I know that you need some kind of the time and let's say preparation for that. So this is that 2 weeks for the projects and also for the laboratories. About the lecture, so maybe I will show the presentation. Yeah, I think this is okay. I hope you can see the screen with the presentation.
Yes, we can.
Okay. One thing that I have still opened chat windows. So whenever somebody wants to ask a question or something like that, please write there anything, and I will be seeing it. Yeah. So let's start. This will be a, let's say, initial lecture. So I think I'm pretty sure it will be shortened than normal. This is a kind of my rule I want to follow. So the little bit shorter, let's say, first lectures, in order to fulfill other additional things we have to discuss. Yeah, general rules about this course. This course is ending with exam. So it means that we are gonna have to write a test during the examination time in the end of the semester. Participation in lectures is recommended due to the level of details in materials. So I am following the rule that I'm placing minimal amount of the information on the materials, on the slides, because I'm providing the slides before the lectures, so you are able to make some kind of your notes on that. And I think this is the best option to learn and the best option to know it, because when you are, let's say, focusing to write something on the paper, on the material, you are really trying to, let's say, remember all those things from the very beginning. So I think this is a nice thing to do. So you will see how the slides will be looking like, and you will, let's say, get that feeling what I'm talking about. So once again, it is recommended to be on the lectures. I don't want you to be, this is not strict thing, but from the perspective of the level of the information in the materials, it is nice to be here and let's say put some notes. Also, there is another, let's say, reason why it's worth to be on the lectures. There will be a project labs, communication will be based on Microsoft Teams, lectures will be based on Zoom. So basically we'll be calling in on the Zoom platform. Labs and the project will be using a portal as a place for delivering results. The same will be for the lectures. So the lectures will be provided, the slides will be provided on the ePortal, and we'll be using ePortal for everything regarding the lectures. And there is final grade equation, as you can see. So 30% from the lecture grade, 30% from the project, and 30% from the labs. So basically, lectures here are a little bit, let's say, important than the projects and the labs. But I think that, okay, maybe I don't think about anything about it. So basically, this is the rule about the grading. As I said on the project and the labs, we are going to use the Python and the OpenCV. Why? Because frankly speaking, this is the best option for you from my perspective. There is also allowed usage of MATLAB, but my exercises and the things I will be showing you and other materials will be describing things in OpenCV in the Python and all that libraries in the Python. So basically, whenever somebody wants to do something in the MATLAB, he is on his own. But you know, you are the student, so you are going to find out and solve problems in dynamic, let's say, environment in the different options. So basically, it's up to you whether you want to use the Python, whether you want to use the MATLAB. If you want to use the C++ language as a base of your things, okay, it's not a problem for me. As I said on the laboratories, I think the Python for me is a kind of the hammer, and the thing we are going to do is to put the nail into the wood. And this is, we can do it in a different ways. For example, you can take a rock, you can do it by a hand, but I think that Python, this is the hammer in this situation, so the best option for that. And I think for free, you're learning somehow another language, programming language. Maybe you will get in love with that Python and all that things we are going to use. It would be nice to get some kind of the self-explaining code. In the Python, it's quite easy because in the Python we call it syntax. Oh Jesus, I forgot that word. A syntax liquor. So basically, it means that you are able to read the Python code as a kind of the book. So basically, you are taking the guy from the street who has never programmed. You are showing the Python code, and probably he will be able to say what's happening there. So basically, this is the Python. And sugar syntax, I was meaning. That was that thing, sugar syntax. And this is the let's say, the feature of the nice programming languages that you're able to write the meaningful code. Many comments will be also advised. The thing I'm going to put the grades on is the functional aspect. So basically it has to work because you are going to be engineers, okay? You will be able to build starships. You will be able to build the different things. So it has to be working. So this is more from my perspective, not only nice documentation or the, let's say, comments in that documentation. About the lectures. So once again, rules, the materials will be published in the portal, or at least on Sundays before the lectures. Oh, this is the law, this is from the previous time, but I think the Sunday is quite enough still because I will be able to put that material on Sunday. Okay, so probably I will be putting on Sundays, but sometimes it might be a little bit, let's say, delayed, but I will be telling you about that. As I said, materials will be less detailed. It's this mandatory making notes during the lecture. This is that thing I want to, let's say, do it. There will be exam at the end of the semester, and this is the another reason why it's worth to enjoy to be on the lectures. There is a possibility to pass without the exam, short test to big held, get 75% of total points to pass without the exam. That short test, I was talking about it during the laboratory in one of the group, may probably have already met grant some tests or hash tests or something like this. So that test that will be based on the material you have already heard on this current, let's say, lecture. And you are going to write the test in the end of that lecture about the material you have already heard. And whenever you are going to get the 70% of total points from that test, you do not have to write the exam. So it will be equal to some kind of the grade there. So this is another reason why it's worth to be on the lectures and why it's worth to be.
Sorry, I have a question. Yeah. So basically the test is from the single lecture, right? The current one.
Yeah.
Okay.
It might be the situation, but we will be, let's say, agreeing, making the agreement about it. That for example, from one, let's say, from one lecture, it would be not enough material or something like that, and it will be for example, 2 tests from the 2 previous lectures. So one that has been already, let's say, presented, and we are writing the test in the, let's say, in the same day, and a week ago, yeah, something like that. But it will be totally agreed between all of us. So basically, if you don't want to have such thing, sometimes it will be possible, sometimes it won't be possible. Sometimes, for example, in the last year, it was that situation that students came to me and say that they have a big test and they have not, it will be better for them not to write test today. So I said, okay, there is no problem, but next time we are writing the test from this one and the next lecture. So basically, this kind of the agreement here has to be followed. So this is how it's going to work. About that short test, about how it looks, the next time we'll write the, let's say, the test. So basically, you will be able to see how it looks like. And from the third hour lecture, so something like the, I do not have the, I have to go out here. So we have the 8th of the October. In the 22 of the October, there will be a normal first test. In the 15th of the October, it will be the first initial test. Let's call it that. All right. I hope that everything is clear for you. Whenever it's not clear, you can ask me always on the Microsoft Teams. You can gather the questions also and put it to the senior student, and that senior student can send to me whatever you want. Okay, so I'm open to questions. So whenever you have the questions right now, you can ask them right now also. Okay. Let's talk about the program or the course itself, because the rules and how it's going to be, I think it's clear. About general program, so we are going to say something about the artificial intelligence and computer vision systems. There will be introduction. We'll be talking about the searching problems, uninformed and informed, about local search algorithms, min-max, about knowledge-based agents, representation of knowledge, image acquisition, noise filtering, shape detection, object tracking. So that would be the things that we are gonna do here and discuss about. This is another point in which I would like to emphasize that the way the materials are created. So I think, and from my experience, the picture is worth 1,000 words. This is the known quotation, but it is working. Okay, that quotation is really working. Whenever I can see something on the picture, I don't have to read several lines of text, and it might be more information there on that picture, because when we are talking about the text, when we are writing some kind of the paragraph, some kind of the bigger text, there might be situation that it will be not, let's say, that the given elements of that text or the portions of that text will not fit together. Okay, in the picture everything has to fit together, because otherwise it will be all not acceptable in the first glance from that perspective. So this is also the way why I'm doing that slides, that materials I'm presenting, that thing. Yeah, general basic idea, maybe the question, why we need computer vision and artificial intelligence. Okay, we don't need it for, let's say, detecting the cats on the pictures or something like that, or detecting the cookies, or we want to do something more, okay, about the computer vision and artificial intelligence. I've told you already on the project that generally computer vision feeds AI with some data. This is how it's going to happen, and it is how it is going. It is done all over the world. This picture is coming from this work. You can try on. I think this is the picture is not showing exactly why we need the computer vision and AI, but it is, let's say, showing how we can compose that elements and create something bigger. There is a general idea in the robotics. I'm coming from the field of the robotics, and the robotics is totally best, I think, option when we can put all that two elements. And so there will be some kind of the stories about the robots and other things during our lectures. But I will be not focusing too much on that aspect, but rather the computer vision and AI in the robotics and other things, because this is the part of the science which is, let's say, developing very fast. There is a common strategy, methodology, I don't know, common idea, idea, that it will be the nice word for that in the robotics, that the robots are based on three things: the sensing, thinking, and acting. So basically, they are gathering some informations from the environment. They are trying to process that data, and they are doing something. Here we have situation that this is the robot which should be the something called the social robot. So that social robot, this is the robot who who makes some interactions with the people. And this is not how the normal robots in our life do interact, but we are thinking about more abstract interaction, or abstract interactions we can compare to the interactions between us and the animals. So for example, it will be nice that it will be a real success whenever we will treat a robot as a kind of the pet, and like a dog or a cat. From that perspective, this is a big bunch of science need to be put into that robot, because I'm not saying only about the engineering stuff, that motion, that I don't know, motors, sensors, something like this, but that element responsible for processing that data, that thinking inside, must be a little bit. It will be let's say, a big work to be done, because that robot, it's using simple if statements or the while loops, it will be not enough for doing that. It should be more abstract thing, for example, to robots to mimic the emotions, because whenever the robots will not mimic the emotions, will not start to think that that robot is sad and it will be really sad, then the social robot will not be able to be created. So that thing has to be done here. And this is the one of the work in which the authors created a robot that was to work with the children with autism. Children with autism, generally person with autism, but rather we are thinking about the children with autism. It's another good option for creating a robot, because the robot can be a nice assistance for that children. Sometimes that people with autism has a problem with, let's say, processing. They usually have a problem with processing the data, but they are, let's say, very sensitive to some kind of the schemas, to some kind of the things that can be done using a robot, but people has a problem with doing that in that way. And this is a nice thing to where we can put the robots. Imagine the situation, there was a kind of the robot also created on our university some time ago. It was the inflatable ball. It was called Koala. And it was also for the people, for the children with autism. Of course, that robot was not, it was some kind of the 15 years ago or 20 years ago. That robot was not able to, let's say anything, do anything more than just to move a little bit, and to, since it has the lights inside, LED diodes, it was able to change the colors, for example, and it was enough for the children, because it was a kind of the toy that was not, let's say, using some kind of the schemats to work, but it was totally random working, and it was enough for them to have a conscious, let's say, put some kind of the focus on that robot. It was inflatable, so that person with autism was able, let's say, to grasp it and to put some strength on it and to, let's say, touch it and feel it. And it was shining, glowing with the colors. It was moving because it was kind of the ball that inside was able to move using the way it has changed the center of the gravity inside, and so on and so on. So this is a nice also field to put some robots in some kind of the problem regarding the autism and other things. But let's back a little bit to the science of here. So basically, as you can see, this is the bilateral cooperation between the robot, because the robot has some kind of the dynamic behavior. Let's call it behavior, because people has a behavior, but the robot, we think, should not have the behavior. And the robot is able to get some kind of the feedback, reinforcing feedback. So basically, whenever the child is not very feeling well with the robot, he can change its behavior in order to get familiarized with that child. And whenever that child who feels bad, feels okay, the robot starts to, let's say, focus on that behavior that helps that person. Okay. And when we have a robot, we have an environment. With that environment, we have to get some kind of the informations, and we are using the sensors to get it. Sensors are being put to the element which is responsible for thinking. So we have the processing algorithms, and that processing algorithms give us some kind of the other thing, for example, the control mechanism that being put on the, let's say, actuators on that robot. And when we are talking about the computer vision, this is the place where the computer vision might be. So we are sensing. So we are trying to get, for example, the image from the camera and process it a little bit, or that processing also might be here. It's not very strict border here. And AI generally is rather here. So we are thinking, so we are trying to do something. So we have some inputs and we have to get some outputs here. Generally, what is the machine learning? This is the meme which is showing what generally the people are thinking about the machine learning. Okay, society thinks we are This is the robot, okay, this is the brain connected to the wires, okay, and as we can see, frankly speaking, what we are really doing, we are writing the code. Machine learning is nothing more than the kind of the code. It might be sophisticated, it might be easy. I found some kind of the meme that was showing that neural networks are just the ifs conditions in the big number and nothing more. And basically, this is somehow a true thing, because this is what it has, what's inside. But frankly speaking, AI, this is the intelligence for machines demonstrated by them. So basically, something which gives us impression that machine is trying to think. It's of course, machine cannot think. A machine can be programmed, computer can be programmed, robot can be programmed. So the intelligence will be equal to that. We will program it. So basically, this is it. And about the problems of AI, we can figure out there are several things we are focusing on. Reasoning. So we are getting, let's say, we are getting some kind of the input and we are trying to reason something, estimate something. Knowledge representation. So basically how to store the information. Learning. So basically taking into account the historical informations and getting some kind of the feedback. Planning. So basically how to do something. So move from one point to another point in the map, avoiding the obstacles. And for example, making not too big effort, and perception and other things. And the tools, these are the network networks, which are the machine learning thing, mathematical optimization, and statistics, and so on. So basically, the AI is a big amount of things inside. And one of the things, for example, is machine learning. So the neural networks, but not only the neural networks, but also the mathematical optimization, that statistics things, and so on, so on. So basically, this is what the AI is. There is a error here, as you can see. This is the computer vision. Computer vision is a part of the science or the thing that helps the machines to see. And computer vision consists of hardware solution, because we have to have as hardware sensors, and software solutions, because we have to somehow process the data. So this is the computer vision. And generally, what's the image? As you can see, this is the image of the Lena for Sen, probably. You can read about it on the Wikipedia. And there is a quite nice history about this picture, because this picture was used by one of the team who was working, I don't remember right now, about the scanner or the algorithm for the computer vision. I don't remember. It was, I don't know, 70s, 80s, something like that. And they want to try something, and they needed a picture. And they had only the one, they were, let's say, in the laboratory, they needed a picture, and they had only the one Playboy magazine. They take out the picture of the Lena. This is only the part of the picture. I encourage you to see the whole picture. And they scanned it, do it something, and from that perspective, from that moment of time, this picture, I think, is well known. And this is the kind of the thing, the holy grail of the OpenCV things. And this is the picture, I think this is most probably seen in all articles regarding the computer vision things. It came to that point that Lena, currently, I don't know whether she is still alive, but some time ago, she was asked to join the computer vision conference, and she put some kind of the lecture there about, I don't know, something, but she was a honor guest there. So this is a kind of nice history about that picture, why it is well known, why it is used, and what is the history beside it. But from the perspective of our, let's say, understanding what's in an image from our perspective is a kind of the map. As you can see, here it is. This is the square, of course, but it has some height, it has some width, okay. And inside we have pixels, so simple cells with some numbers inside. So we can arrange or treat an image as a kind of the table or array. And image can, for example, the basic representation is about to use the color image with the RGB scale. So red, green, blue components of the pixels. So each cell, frankly speaking, is composed of 3 another numbers. And there is also the possibility to have a monochromatic image. So it means that we are having the numbers from 0 to normally 255, and this is describing level of grayscale we are using. And basically the image we can treat as a that table, but also we can treat the image as a kind of the 2D graph, 2D signal, frankly speaking, because we will see that image, for example, have some kind of the things regarding the frequency aspects and other things. So the image, once again, is a representation of some let's say real image on the plane, as you can see. It can be treated as a array table. It can be also treated as a kind of the signal, 2D signal. This is the mathematical representation. So this is the static planar projection of the visible scene. It means that we have 2 eyes and our brain does the magic, and we are able to say that something is in some kind of the distance. We are not able to say what it is equal or strict distance, but we are able to say whether something is closer or the not closer. And from that perspective, this is nice thing about the image is that when we are making the projection of that 3D scene into the 2D scene on the plane. So basically we are, let's say, losing the information about the depth here. Of course, we are using also the information about the coordinates, because when I'm, for example, sitting right now and I'm looking somewhere there, I know that that element is on, let's say, something like the half a meter on the left, half the meter on the into the up direction, and in the distance of 3 meters from me. So I can say in the space, I can put in the space that element. But in the image, it will be, all that things will be translated into the planar scene. So basically it will be the pixel number 251 and 361, for example. When we are talking about the image, normally we are indexing the pixels from the left top corner. So basically the pixel 0, 0, because we love the IT, we love the computer science, and we are starting to count from 0, are here, okay, left top corner. And on the right hand, on the right border, there is the row now 0, but the column equal to the length or the, let's say, the size of that image. So basically it might be the picture which is 1000 per 1000. So it means here we have the pixel on the position 0, 999, because we started to count from 0. So basically in the sum we have 1000 elements. Basically how we are seeing the things. So I don't want to get into details about that thing, but basically the light beam is, let's say, reflected, and it is coming to our eye. It is going through our eyelid and so on, and it is going to the cells that are responsible for getting the sensations. So this is the energy which is being translated on the some kind of the analog signals in our eye, okay, and our brain consumes that information. And we have two different types of the sensors, and one are the whoa, I lost right now the word. One are the sensors responsible for, let's say, getting colors, okay, and the another element of the cell are responsible for getting the not the grayscale but the amount of light there. Sometimes people has a problem with that second and of course with the first one. So whenever we are having the problems with the colors, you know, but when we have something problems with that second type of the cell, we have the problems with seeing after in the night, for example. So we are not able to see some tiger coming to us in the jungle. Okay, and yeah, so basically this is it. What I want you to understand during these lectures, during these things, that treat the image as a kind of the signal, 2D signal, as I said several times till now, because it means that we can apply all that things we are using normally for signals. For example, Laplace transformation, of course, but generally we can place the Fourier transformation. We can filter generally that idea that this is kind of the signal we can process, and we can do something with that, enabled the possibilities to use the different tools for finding the nice things. For example, on this picture, we can detect the contours. And maybe another thing about the picture. We are, let's say, able to determine two major types of the pictures. One picture will be the picture with many details and many edges, because the edge means that there is a giant difference between the pixel values from one side to another side of the edge. So basically, much happens there. And it means this is the place in which we have situation that a big frequency is being generated. So basically, pictures, images with big amount of details, with big informations, big number of edges, these pictures are called high frequency pictures. So yeah, and basically when we are talking about the subtle pictures, for example, maybe I will show you. These lectures will be held in that way that I will be showing something on the materials and also in the net. Yeah, for example, this kind of the image, as you can see, this is the gradient of the grayscale. So we are coming from one value with each pixel to another value, and you cannot find edges here. So this is this totally, let's say, low frequency image. Yeah. And about this grayscale, as I said, we are normally starting from 0, which means we are talking about the black color, and we are ending with 255, and it will be white color. With RGB, it's quite the same. So the 0, it will be not black, but generally very dark red, and green and blue. And 255, it will be very bright things. So you can find out also. There are some kind of the other representation. There is also HSV. So this is the representation which is shown as a kind of the cone, where we have the hue, saturation, and value. And this is kind of the, let's say, representation which is also used in many things. But the most important, and I think mostly met, is that RGB. Yeah. All right. So we talked about the images, how does I see things, you know, that as I said previously, basically our brain does the magic because it was learned by several years how to proceed with data, how to process the things inside him. So basically we are able to see the things that normally we will not be able to see because we have learned it. And basically this is the scope and the work we have to do regarding the computer vision algorithms, because generally we have some kind of the sensors, we have some kind of the cameras, and we have to do something with that. All right. So it was the first lecture, and I think I will start with the next lecture because I already talked about some elements here. Yeah, so another thing about the way that I'm going to show you the lectures. Normally, I'm starting the new lecture with some kind of the recap from the previous lectures. So basically, you will be able to see some kind of the things that I have already been showing. Yeah, about the light can be treated as a, you know, that particle and a wave. And whenever we are talking about the light visible the spectrum, we can see this is that, let's say 400 nanometers to 700 nanometers, maybe more. And here we can see there are different, let's say, colors we can distinguish between them. Okay. You know that human eye construction, it's quite easy to understood. These are that cells I was talking about and I forget to name. So cone cell is responsible for getting the colors. As you can see, we have the blue, red, and green. And that's rod cells. Rod cells are responsible for getting the, let's say, light into that. Of course, this is, I think, some kind of the simplified picture, but you can find out this how it is looking really like in the nature. About the human eye construction, the people try to mimic the nature, and they also tried to mimic nature in this field. So they have constructed the sensors, which are composed quite similar to the things how the eyeball or the eye is constructed. So we can hear sensors responsible for getting the light into that. This is the CMOS matrix. So basically, this is photo detectors, which are, let's say, sensitive to the light, and they are getting some light sensations. Okay. And when we put some kind of the magnifying here, we can see that there are some cells responsible for getting the red, green, and blue elements. Yeah, and I think this is the moment I want to stop for now and for today, because we will not be able to see other things or to discuss other things next time. Yeah, so basically this is it. We were talking about what is the picture, what is the computer vision, what is the artificial intelligence. Maybe another thing that I will be talking about in the very beginning of this course about the computer vision stuff, and then I will switch to the artificial intelligence stuff. Because as I said, our computer vision should fit the data and put the data to the artificial intelligence. But and I think this is the right order, and I think also it will be easier for you to get that things regarding the computer vision. Yeah, do you have any questions right now? Okay, I cannot hear, and this is the normal moment in which people start to say I have a question. But yeah. So this was everything for today. As I said on the very beginning, this is my, let's say, this is my way that the first lecture is shortened than other. Maybe it's coming from some kind of the tradition. I have met during my studies on this university from one of the professor, and I let's say it was nice for me, and I'm trying to do it also in that way. So thank you very much for today. If you have any questions, please write me on the Teams. Have a nice day, and see you on Tuesday and Thursday, and hear you on Friday. Thank you.
Thank you.
Goodbye.
Goodbye.
Thank you. Goodbye.
Goodbye.